In lesson 8.4, we learn about determinants. The determinant of a square matrix, so you can only do determinants of square matrix, maps the matrix to a real number. The determinant is denoted with this symbol right here. We have like an absolute value marks around the name of the matrix, or as you can see here, you actually can put the marks around the entire square matrix. What we're going to do is we're going to learn how to find the determinant of 2 by 2 and 3 by 3 matrices. Really straightforward. And then we're going to learn how to find the determinant of any square matrix. You can use it for a 3 by 3, or what we normally use it for are the higher matrices with more rows and columns. So, determinant of a 2 by 2. This says if A is a 2 by 2 matrix and A equals A, B, C, D, then the determinant of A, which is the determinant of A, B, C, D, simply equals AD minus BC. And now what you'll notice here, this is A times D minus B times C. So nice and simple. You multiply the ones in the diagonals, and then you subtract. So you always do this main diagonal first, which is the left to right. So 2 times 1. So the determinant of B is 2 times 1 minus 4 times negative 3, which is negative 12, so we get 14. And it's as simple as that. So let's do one more. 3, 7, negative 1, negative 2. And we want the determinant of that, because I have those marks there. That is going to be 3 times negative 2, which is negative 6, minus 7 times negative 1, which is negative 7, which is the same as negative 6 plus 7, so it's 1. All right, this next section, this should say something like a 3 by 3 determinant. And we're going to do that in 2 ways. First way is diagonals, and I'm just going to talk you through this, kind of giving you steps along the way. But what you do to find the determinant of something with by using diagonals is you actually take the first 2 columns and rewrite them. So this is going to be A11, A21, and A31. And then the second column is A12, A22, A32. Remember, these numbers here tell us that we're in the 3rd row, and then 1 is the first column. All right, but we're not going to use that right now. All right, so once we rewrite those, we're still going to go left to right, and we're going to multiply these. So we'll do these highlighted left to right. We'll multiply those 3. We will multiply these 3, and we will multiply these 3. You always want to multiply 3, and that's why we don't continue this pattern here or here, because we would only be multiplying 2 things. So you find those 3 products. So this is going to be A11 times A22 times A33, and then A12, A23, A31, and then A13, A21, and A32. So you multiply those, and then what you're going to do is you're going to add them. That's your first part. So that's, in comparison, that's really just doing this part here. There were no more rows. So it's multiplying that way, but here we multiply and we add those products. And then we're going to subtract. And then we're going to come back the other way. So we're going to come back the other way and we're going to multiply these 3. And that's A13, A22, and A31. It doesn't matter what order you multiply in. And then you're going to multiply these 3 coming right to left. So that's A11, A23, A3, 2. And then we have our last product here, and that's going to be A1, 2, A2, 1, and A3, 3. And you're going to add those together. And then to get your answer, you're going to subtract those two sums. So let's take a look at this example. It says, let C equal this matrix right here. Find the determinant of C. So we're just going to follow that diagonals idea. We'll have to rewrite these. So we have negative 1, 2, 3, 0, negative 5, 2, 3, negative 3, 2. We are going to rewrite our columns, our first two columns. So this one and this one. Be careful to copy them correctly. And now we're just going to do our multiplications. So we'll come down and do these three products. I'm going to do the products. I'm not going to write it all out. A lot of the times we can do this in our head. So we have negative 1 times negative 5 times 2. That's 10. And then we have 2 times 3 times 2. That's 12. And then we have 3 times 0 times negative 3, which is 0. So we did those. Now let's come back the other way. That's 3 times negative 5 times 3. That is negative 15. Negative 1 times 2 times negative 3. That's 6. And then 2 times 0 times 2 is 0. And so we have 22. I apologize, I messed up here. This sign here in the middle is subtraction. I don't know why I put an addition there. This is subtraction minus negative 15 and 6 is negative 9. And so we get 31. And that's how you can do a 3 by 3 using diagonals. That method only works for 3 by 3s. All right, moving on to the other method. We're going to have to find out or learn some terms first. So here we go. Here's our terminology, the minor of an entry. The minor of an entry. So this is in a 3 by 3 matrix. The determinant of the matrix resulting when the row and column of the entry are crossed out. So let's see what that means. What is the minor of 0? So what we're going to do is we're going to find 0, and we cross out the row and column that 0 are in, and we're left with 2, 3, negative 3, 2. And so it's the determinant of the matrix resulting when the row and column are crossed out. So we want the determinant of this. So 4 minus negative 9 is 13. So the minor of 0 was 13 because we crossed out the row and column. We saw a resulting matrix and then took the determinant of it. We don't have to physically cross them out. We can just mentally think what matrix we would have left. So let's do another one. Let's find the minor of negative 3. So here's the negative 3. So what we want to do is we want to think the determinant of if we cross out the row and column that 3 are in. So we're going to cross out the row and column that 3 are in. Again, you can do that mentally, or you can cover it with a pencil or something. But we have negative 1, 3, 0, 2. We want to find the determinant of that. That is negative 2 minus 0. So it's negative 2. So that's how you find the minor. We're going to be using that shortly. The next term is the cofactor. The cofactor of an entry is negative 1 to some power. I plus j, that's the row that you're in, plus the column that you're in. And negative 1 to a power is either going to be negative 1 or 1. because -1 to an even power is always just equal to 1, and -1 to an odd power is always -1. So really this is going to be changing the signs. And that's what we have over here. If we think through this, this is first row, first column. And so we add those, that's a 2, which is even. And so that term is going to be positive. And actually, it's not necessarily positive, it's just that we don't change the sign of that when we get there. So notice we just have alternating signs in both directions. And we will take a look at that later, but it's easy to remember the alternating signs. Now, actually, all we talked about was the alternating signs. The cofactor of an entry is the -1 to a power times the minor of whatever entry we're talking about. So it's multiplying 1 or -1 times the minor, which we just did up here. So find the cofactor of -5. Well, here's -5. What we're going to do is we're going to think that's -1 to the, and this is in the second row, second column, 2 plus 2. So -1 to the 2 plus 2 power times its minor. Well, remember from above, the minor is when you cross out the row and the column and you have a matrix left over. And so -1 to an even is just 1 times the determinant of this. That's -2 minus 9, which is 1 times -11, so it's -11. Another way to think of it is of whether it's going to stay the same sign. So basically a positive means keep the sign, negative means change the sign. So we could have looked at this and we could have seen that a positive means keep the sign, and so it was -11, and we kept it as -11. All right, so those are a few terms. Now we're going to go through this idea of what's called expansion by cofactors, and this is going to be finding the determinant of a 3x3 or 4x4 or 5x5 using this idea of cofactors. So what you want to do is you want to start by selecting a row or column. When you do that, we like zeros. In fact, we love zeros. Zeros make things a lot easier. So if you can find a row or column that has zeros in it, that's great. Ones and -1s are also nice because they're easy to work with. So we're going to select a row or column, multiply each entry of that row or column by its cofactor. Add up the products found in step 2. Okay, so what I'm seeing here, I actually like this second row. This second row right here. Because it's got a 0 and it's got a -1. We could have gone with the third column, would have also worked fine. Actually, any of them work fine, but we want to utilize that 0 because we love zeros. All right, so we're going to go ahead and work with this second row. So that was step 1, that was the easiest one. Multiply each entry of that row or column by its cofactors. So we're going to take each entry of this row or column. Well, this one's a row, so here's the 0, here's the -2, and here's the -1. We're going to multiply each entry by its cofactor. Well, its cofactor is when we cross out the row and column and find the determinant of that, and we have to determine if we change the sign or not. So remember this little pattern, plus, minus, we're going to do negative, the opposite. So remember, a negative means opposite, and positive means keep it the same. So we're doing the opposite of that. In fact, I'll put these in orange. We're going to do opposite, same, opposite. And now we do the minors, which we're going to cross out the row and column that zeroes in. And we have 1, -3, 4, 0. This part has nothing to do with these little signs, these plus and minus signs. Now, I didn't even need to write that because 0 times anything is 0. So that's going to be a 0. And then we are going to add this next one. We have -2, which it's hard to see because I crossed it out. -2 times its minor. So that is, so cross out row and column and row. And we have -2, -3, 3, and 0. And then we do the last one where we cross out the row and column. So we're going to cross out row and column. And we are left with -2, 1, 3, and 4. And then once we figure out all this stuff, that will be our determinant. So here we have -2, 0, minus -9. And then here we actually have plus, which is 1. That doesn't matter very much. -8, -3. And so we have 0 plus, this is +9 times -2, so -18. And we have -11 times 1, which is -11, which equals -29. All right, and then we have a 4 by 4 here. Again, we like zeros and ones, so in fact, this first row is going to work, first column is going to work well for us here. So let's work through this. We're going to take the 1 at the very top and multiply by its cofactor. So this is going to be plus, minus, plus, minus. So we have 1 times its cofactor. That's when you're going to cross out the row and column. And we're left with the determinant of 0 to -1, -1 to -2 to 1, -4. And we'll work with that later. Now what we're going to do is going to take that 3 and it's -3. And so we do -3 times its cofactor, which we're going to cross out the row and column that is in. And we're left with -2, 1, 4, -1, 2, -2, 2, 1, -4. And then we're going to come down to the 1. It's going to be a plus 1 times its cofactor. And so what I'm going to do here, hopefully, is I'm going to cross out the row and this column, and we're left with another matrix that's -2, 1, 4, 0, 2, -1, and 2, 1, -4. And then lastly, we have -0 times its determinant, which we could fill in, but I don't really care because 0 times anything is 0. So I don't care what that is. It's 0 times whatever that is. All right, so now let's work through this. Let's go ahead and use diagonals for this one. So we're going to 0, -1, 2, and 2, 2, 1. So we have 1 times 0. So we're multiplying these diagonals. Plus -8 plus 1 minus, and we're going to come back the other way, it's -4 plus 0 plus 8. So that's that one. And then we have -3. And we can do the same thing. We can use diagonals here. You could use cofactors here as well. So we have -2, 1, -1, 2, and 2, 1. It's 3 times this determinant. So we have that's 16 -4 -4 minus, and we're going to come back the other way. That's 16 minus 4. I'm sorry, that would have been a +4. +4 +4. And then we have this next one here. So that's a +1. We can rewrite these. And we have 16 minus 2 plus 0 minus 16 plus 2 plus 0. And we're almost finished. So now we just have to do some adding and multiplying. So this one we have 1. So we don't even need that 1 there. We have -7 minus 4. Then we have -3. And we have 16 minus 4. We have 8 minus 24. And then the last one, we have 14 minus 18. And so we have -11, -3 times -16, plus 1 times -4. And so we have -11 plus 48 minus 4. Let's see, 48 minus 4 is 44, minus 11 is 33. So our determinant of that 4 by 4 matrix is 33. I know that's tedious, not a lot of, not too hard, but it does take a while. All right, the last thing is just another term, the transpose. The transpose of a matrix A, denoted A with a superscript of T, is obtained by using the respective rows of A as the columns of A transpose. So all we're going to do is we're going to make the first row the first column, and the second row will become the second column, and the third row will become the third column. Or another way to think of it is the first column will become the first row. And so find R transpose. Well, what we do is we make our first row our first column. And then we make our second row our second column. And we can make the third row, that's now the third column. And that is the transpose. Also notice what I said earlier, the first column becomes the first row, and the second column becomes the second row. So that is the definition of transpose.